Moving on from the last video where we discussed the chi-squared test for homogeneity, we are now going to move into the chi-squared test for independence. These are technically the exact same tests. So the math behind them, the statistics, is exactly the same. However, it's all about the wording and mostly in our hypothesis and in our conclusion. Let's quickly walk through this example. This is the difference here. Is the first variable in context is independent of a second variable in context. That's one way to write it. You could also say there is no association, which means independence. The alternative is there is an association between the second and the first variable. So this is all about comparing two variables to each other. We're going to have the random is going to be stated or somehow assumed, 10% or independence, it's less than 10% of the population, hopefully. Large counts, expected counts of each cell is greater than 5. So the procedure is we're going to have a chi-squared model for a chi-squared model or normal model for a chi-squared test for independence. I usually just say conditions met for a chi-squared test. Expected count, same as before. Degrees of freedom, same as before. Finding chi-squared, same as before, and the same as before. All the math is the same. And we are pretty used to this by now. The conclude is the same. P-value is either going to be so small we're rejecting, or it's so large we're failing to reject. Let's dive into an example about Montana. Wow, this is a really old poll. 1992, University of Montana classified respondents by gender. This is often a common category, and their political party. So we want to see if there's an association between gender and party, or if these are independent. Like if I picked male, they weren't more or less likely to be part of a certain political party. So the null is the political party is independent of gender in Montana, or you could also state that as there is no association if you like to keep it so you only have to remember one thing. There's no association between political party and gender in Montana. And then there's the alternative. So the plan random, although not specifically stated, we can assume the poll was conducted randomly because it did say it was by the University of Montana. So I think we're safe to assume this was an academic study and they used good research methods. 10% or independence, we can assume that the 202 is less than 10% of the population of respondents. Large counts, let's see, we're going to see the table here below. We can see all of my expected values. We calculated that just like we did in the previous video. So we've got, let's see, so all my expected counts, 43 something, 40, 40, 37, they're all greater than 5. That's good. They did the degrees of freedom here. You don't have to, but the conditions are met. So we can use a chi-squared test for independence. So it looks like they've already calculated all of our expected values. So let's look at the do. I'm going rather quickly here because we did see a lot of this in the previous video. But if we were to calculate by hand, here's what our chi-squared would look like. I don't know if I would do this for 6. That's a lot of calculator work to get to 4.851 for our chi-squared value. When we look on the table, we can see that our p-value is somewhere between 0.05 and 0.10, which means we are going to fail to reject. That is higher than 0.05. If we did it in the calculator, you can see the calculator steps here. Now, also note right up here, we calculated the degrees of freedom. We had 2 rows, -1. 3 columns -1 would be 1 times 2 is 2. So that's how we got our degrees of freedom. And if we do a chi-squared CDF, our chi-squared value, a large number, and then degrees of freedom 2, would give us 0.08 and some change there. So alpha was at 0.05, and we can see we're going to conclude the p-value is so large, or just is larger than alpha, we fail to reject the null hypothesis. There is no evidence to suggest there is an association between gender and political party in Montana. All right, folks, really, I just wanted to quickly go through that. So the only difference here is being able to recognize that this was a test for independence. We were comparing gender to the different political parties. It looks like there's really no difference whether you ask a male or a female. And then the previous one, the homogeneity, that is when you're trying to just compare that table to the expected values and see if there is a difference. All right, well, that's everything. Let me know if you have any questions, and we'll do one of these in class.